Hey everybody, this is Brian. Welcome to the 120th tutorial with Qt and C++ programming. Wow, 120 of these things. Gonna not do a lot of typing in this tutorial because I'm very tired. I'll tell you a little story, children. I work as a server administrator and network administrator for a company. I'm not actually a programmer. That's not true. I've been a programmer most of my life, but my bread and butter comes from babysitting a network. Where I live, for whatever reason, there's not a lot of computer jobs, and the ones that are just real low pay, and you don't want them. Anyways, we had a water pipe break in the server room, and the entire building flooded. So we've just been ripping out drywall and having a good old time while running a business on top of it. So, wanted to do a quick tutorial. But I don't have time to do it over and over and over and over again. A lot of times when I do a video, it takes me 8, 9, 10 tries to actually get it right. And I just don't have the patience for video editing software. I just don't. So anyways, today I kind of wanted to point out that we have broken the 3.5 million views and 22,758 subscribers. That's a lot more than I ever expected. I started doing these videos for my daughter, who completely lost interest in everything except for Facebook and all the things that teenage girls like. But I still program, and I'm working on a few projects. So if I had $1 for every one of those views, or even for every one of those subscribers, what would I do with it? Well, I'm glad you asked. I would put it into my website, voidrealms.com. Complete sales pitch here. You can find the complete source code for all the tutorials, including this one, which I'll be uploading here soon. So you can head out there and click on tutorials, and then choose the language, and then search for whatever you're looking for. So if you wanted, like, I don't know, AES encryption, well, I thought I had that. Encrypt. Yeah, there we go. How to encrypt. Sometimes I'm not very good at filling in the descriptions, but you get it. This tutorial would be talking about Singleton patterns, which is where you create one class and you guarantee to only have one instance of that class running at any given time. It's part of the pluginbot.net project. Be sure to visit pluginbot.net. It's my newest pet project, and this code is coming directly out of that project. So let's just jump right in. First off, why do you need this? Why would you ever want one instance of your class? Give you an example here. We've got a simple program, and you can see here's our main function. We've got test H and consumer H, and they're just very simple classes. Here's test. You have a static function that does something, literally called do something. And there are many reasons to use a static method, but if you skipped your C++ primer, static method exists without the class, meaning you don't actually need an instance of this class in order to execute this code. And we also have a signal. Now, the problem is we want to call this signal from within that static object. And so here we have it. Test do something. Remember, this is static, and we're emitting a signal. What happens if we try to build this? Boom. Cannot call member test signal without object. So we actually create an instance of this object. The problem is it's a static method. So it exists without an object, exists separately from the object or any instance of the object. So how do we actually call that? Well, you could try calling it as a normal function, but you're going to get pretty much the same thing. You need an object. So we're going to get around that. Let's comment this out. I pulled the Singleton class from the pluginbot.net project. Thought I'd share this. I actually didn't really write this class. I think I borrowed heavily from somebody out on the net. So if this is your class, hey, let me know. I forgot who you are, but I think I read your tutorial somewhere, and this came in very handy. So I wanted to show other people how to use it. I'll give you kudos out on the YouTube page. I did rewrite parts of this to suit my needs, but anyways, you're going to first include assert H, and then we're going to make a template. Now, if you skipped your C++ lectures on templating, you should pay attention because it's going to be very important. A template is, well, a template. They kept it pretty simple, meaning you can throw anything you want. You can throw a string, an integer, whatever. We're just saying a class, and it'll be a variable called t. We could call it fuzzy bunny slippers if we wanted to, but t is the standard. The class is Singleton, and you can see, whoopsie, outside of our class we have a template. We'll get to that in a second. So in here we have one public static function called instance, where we're saying pointer to t, that class. If there's no instance, which is just a static, pointer to a variable, then create a new one. This is templating. See, that class is going to be replaced by here. So if we used a, I don't know, a test.h, class will actually be converted to test. So it's the same thing as saying new test. All right, so then we're going to assert, hence the assert.h. We're going to assert that is not null, and then return the object. So what we're saying is if it already exists, it's going to skip this line, and it's just going to make sure it's not null and return it. If it doesn't exist, it's going to create a new instance, assert it, and then return it. Whew. Like I said, I'm tired, so I'm fighting to stay awake here. All right, now we've got our constructor and deconstructor, and then we've got a, I believe it's copy constructor and a operator overload. I can write a FTP server from scratch, but I still try to wrap my head around operator overloading. I just, for whatever reason, it haunts my dreams. All right, now basically all we're saying is if we are making a copy of it, then just use the reference. Otherwise, if it's equal, then we're using the reference. I'm sure I'll get a million emails saying that's not how that works. I look forward to those emails. Then we're making a template, and we're saying the class T. Here's our template. Pointer to singleton of the template, and then we're returning the instance variable, and it's initialized as null. That's a mouthful. So how do we make this thing work, and what do we need it for? Remember, our original problem is we have a static method. For whatever reason, you want to use a static method, and we want to emit a signal from that static method. In our consumer class, let's actually go here, we've got a slot which matches the signature test signal. So we need to line these up here. First thing we're going to do is go into test, and we're going to say include singleton.h. Now outside of our class here, we want to create what's called a type def in the global namespace. If you fell asleep during your C++ class, don't worry, I did too. Type def is just short for type definition, meaning you're creating a new definition here. We're going to call it singleton, and this is a template, so we're going to use the test class. If you remember from the singleton, it's looking for a class. So we're going to give it a class, test. And we're going to call it tester. So we have a type def, which is this, called tester out on the global namespace. Now if we want to simplify that, we have a variable on the global namespace called tester. And the variable is just a singleton of test. You've done this before with like QList, where you've done a QList of Q strings. That's really all it is. No real magic in the background. Now, because that's on the global namespace, we can do some interesting things here. Personally and professionally, bad things happen when you make a global variable. Let's actually call that a global variable. Because you're cluttering the global area, you have all this junk flying around, and it's hard to track. So it's bad design to do that, but sometimes it's necessary, and this is one of those instances. So in our test class, we've got that, and we've still got this. We're going to fix that in a second, but I just wanted you to be aware this is the problem, creating something without an object. Now in the consumer class, we're going to actually say, let's see here. Sorry, I'm kind of zoning out. I told you I'm kind of tired here. We're going to connect our signals and slots. Now, how are we going to do that when we don't have an object? Au contraire, we do. Remember? We made it out in the, whoopsie, the global namespace, but we have to include it here. No, I don't want terminal IO. That won't help us. I want test. I keep having that phrase in my head, water, water everywhere, not a drop to drink. So notice how in the tester, and we use the namespace, we get instance, which is a pointer to test, meaning the instance that we're guaranteed to get. That's our singleton pattern right there. Now our test signal, connect it to this, slot, test signal. Should have called that test slot. Let's actually do that just for giggles. I'll have to go in here and fix this real quick. And of course in here and fix this real quick. So that way it reads a little better. So we're connecting the pointer to the test class in memory called tester, and we're connecting it to the consumer on the test slot. So when this is called, we'll debug yay. Nothing's going to happen if we run this because we've got this commented out. Let's give it a build. Now, just for reference, if we try to run this, we still need an object. So how do we get around this? Simple. Tester instance, and we're going to say test signal. When you call a signal, Qt treats it as a normal function, but it does some magic in the background and actually emits it for you. Emit just tells it, hey, look for this signal. So we're just going to call that. There's no need to actually say emit. I'm not even sure if that would work, but we could try it. So when we call this, we're going to say tester, our global variable. We're going to get the current instance, which if you remember from our singleton pattern here, we're just saying get the variable that's out in the static area. Static's kind of a weird area. It puts it kind of like out on the global, but not really. It's kind of shifty. There have been some debates. Some people say yes, it's a global, no, it's not, but we're not going to get into that. We simply want to call this test signal from our static function. So when we run it, nothing happened. Let me see if I did this right here. Oh, yeah. It would help if we actually did something with this, right? So we need to go. I told you I was very tired. Tester instance. Do something. So we're calling our static variable. Now, you notice how we're actually not calling static. We're calling it from the object. I want to make that differentiation right here so I don't get a million emails. From the object. We'll run this, and we get, yay, it worked. Now, as I said, we're not actually calling it from the static function. Let's fix that. This is how static functions work. Notice how you're calling the test class the function in it. So we're calling the do something static function. We don't actually have an object. And it still works. Yay! Just to prove that that works, let's actually say consumer. Help if I can spell. It's working. So, quick overview of how this works and why it works. Okay, we've got our test class with a static function. Sometimes you want a static function, most of the time you don't. Remember, a static function will live out in the global area. You don't actually need a class, or I should say you don't need an instance of that class. You need the class itself, but not an instance. That gets into the whole is it an object or an instance conversation, and then we'll start a big war on the forums. But we want to be able to emit a signal from that, but we don't have an object to emit it from. So we of course use a singleton pattern using the test class and create a global variable called tester. From that we can actually make our call, and you see in the do something function, which is static, we're saying tester get the global instance, or the global variable, and then call the function test signal. Now that function is actually, drum roll please, a signal. That's the magic of Qt in the background right there. That's why in every book they say always include this Q object, because that's what happens in the background, is it does all this linkage for you. All right, so real-world practical applications of this. What would you possibly use this for? Well, I was working on a keylogger for pluginbot.net, and it uses what's called a hook, where you hook the keyboard process in Windows. So every time a key is pressed, Windows notifies you. I believe it's called an in-proc or an in-memory hook. Anyways, it has to be a static variable. Well, I wanted to emit a signal saying, hey, a key was pressed. It's the chicken or the egg. You have to use a static function to get the hook, but you want to, you get where I'm going with that. Okay. So once again, a singleton pattern is a method of creating a single instance of that object, and you want that to persist out in the global namespace. Another real-world example would be a logger that's going to write to a file, or a TCP server. You don't want to create two servers listening on the same port. One of them's going to die, so you want to make sure that you have a single instance. Well, that's all for this tutorial. Thank you for watching. I hope you found this educational and entertaining. This maybe wasn't so much about Qt as it was about me just rambling because I've had a long day, and more about like C++. But be sure to visit my website, voidrealms.com, for the source for this tutorial and others, and also check out pluginbot.net. It's in beta, but I'm hoping it does a lot of good for the world. I want to release it free for schools, nonprofit organizations, etc., etc. Really looking for other developers to kind of jump in and help out with writing some of the plugins. You'll get fame, recognition, and women everywhere will throw themselves at you. Joking. Well, and if you're a woman, because there are quite a few women that watch these tutorials, men will throw themselves at you. Unless you don't like men, then maybe cats will just follow you around, because I have like 4 cats staring at me right now. All right, well, that's all.